Okay, now another thing I don't want to spend too much time, just want to touch some bases, is our one tail versus two tail test. Look at this. This is again a normal distribution. Now, if we compare two samples, okay, actually we are comparing uh, two populations, and we say uh, they are really different. So, for example, we compare these gender differences, right? Men are kinder, women are kinder. Suppose you don't have any assumption, like I think a woman should be kinder. Okay, so then you don't know if woman will be higher or woman will be lower, right? Now, if that's the case, remember we say the probability of they are from the same population should be less than 5% in order for us to say they are significantly different. So the 5% actually, because we don't know the direction, which one, which end woman will be this way or that way. So we need to split this 5% on these two ends, 2.5 on here and 2.5 right here. And this is called two-tail test. Without getting into the detail, just want to say two-tail test is a more a strict test. The difference should be more in order for us to say it's significantly different. On the other hand, if we have evidence, research evidence to suggest there's a directional. So, for example, if you find studies that suggest that women indeed are kinder, yeah, you have some evidence to suggest that, then you can hypothesize that women will be kinder than men. And if that is the case, then we can use when we get the data and we analyze the data, we can say this is a directional hypothesis. That means we predict the way the difference between groups will go. And if that's the case, then we can use something called one-tail test, and that's easier to get a significant result. One tail means that all the 5% is one direction. So, for example, if this is a male population, and I assume, female, women are kinder, so it go this way. Okay, so I will not even consider this direction. Uh, so I can put all my eggs, all the 5% right here, all my bets right here, and it's easier to find significant. It doesn't have to take a lot of difference to find the significant. The downside is if in any case your data pointed to this way, then it's not supporting your hypothesis. Now, some people, it depends on who you ask. Some people say, okay, yeah, if you have research evidence, you can use one-tail test. That it's easier to find a significant. But some people they say no matter under what condition, we always use two-tail test because one-tail is like cheating. Um, but actually, I have seen a lot of published work they use one-tail test. So it just depends on different people's philosophy. Okay, so just so you know, one-tail test is easier to find a significant result. Two-tail is more strict. Okay, that's what I'm saying.